Is it making sense? A little bit.
3 minutes.
Hello?
Yeah.
How much time will it take? So let's move ahead. Let's move ahead. So we'll do another test. Okay. Here's a little exercise for you guys. So use this test to show that this series of numbers, which is 1 over n, is divergent. This one. That is that. Now this is something very interesting. I mean, if you see that you did what you call the divergence test, so this is an example that the converse of divergence test is not necessarily true. In other words, if you have a series which is represented by a sequence which is converging to 0, it doesn't mean the series is going to the match. Okay? But if it is non-zero, it is going to diverge that way. That's the same. So the exercise is to basically show that this is divergent plus by doing this. Okay? So this exercise becomes you can take this series. Do you think that this series fits onto this criteria?
Yes, sir.
It fits into this criteria. So I'm saying that show that this series is divergent actually. So for that you can show that this series diverges out, no matter how hard you try. Okay? Why this should be the case? Just think about it. Just substitute the value. What will the a to k is going to be? 1 over a to the k. You have
Okay.
so what's going to happen? So it's like 1 over 1 over n power 1 over n power 1 upon 1 over 2 to the k actually. 2 to the k. The 2 to the k is going to cancel out with 2 to the k itself, and you're going to have 1 plus 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 1. Okay? That is going to diverge out. Okay? Is it making sense? So in other words, here a n is what? A n is what? So it's 1 over n. So what would be a 2 to the k? So it's going to be 1 upon 2 to the k. Just replace n by 2 to the k. So if you replace, here 1 over 2 to the k, so 2 to the k is going to multiply with 2 to the k, so you're going to have 1 here. So you're going to have a series of ones actually, which is going to obviously diverge out by divergence test. So if this is divergent, obviously this is divergent. Well, just think about it. Looks like that. Okay, you have this sum in which every term is getting smaller and smaller and smaller, upcoming term, but still the sum diverging. So you can show actually that no matter, so it's like you fix a number that if this given series is going to cross that number, this sum is going to cross that number, you can always find an n actually. After that n, the sum is going to be bigger than that number. Okay, it's going to take long time, but you can maybe sometimes you need to wait for millions of years. Zero. Better? That's what I said exactly. That this is a counter example that the converse of the divergent test is not true. Okay? You don't have if and only if there. Okay? You can have sequences whose nth term is dying out to 0. Some is divergent. looks like something uninteresting, but you can see that you can get interesting results out of it. Like this. And this series is called harmonic series. I hope that. Like that, harmonic. There is harmony, but the harmony is creating chaos. Huh? So, okay. So, I would like to prove a little theorem, which is kind of a generalization of this result. So it's not only if you have 1 over n, but if you have 1 over n to the p, it's still the series basically. Diverges depending on what is p actually. We're going to say that this sum of 1 over n to the p, okay, diverges. So what is your guess? What should be the index on p? For the divergence should be what? Greater than 1 actually. Bigger than 1. Ah. P is less than or equal to 1 and converges. If and that's what you call it. What is famous name for it? P series test. P series. You see that, how all these simple definitions are kind of giving you proofs for this. Yes. So here's a quick proof, just one-liner proof. If p is bigger than or equal, less than or equal to 0, then what will be the wrong with this test? Or what would be the wrong with this series? ऊपर चला जाएगा डाइवर्ज कर जाएगा by the divergence test. It's going to explode to plus infinity. So divergence. So if p is positive, then consider this. If p is positive, if p is between, is it necessary that the index, the power should be always positive? It could be negative as well. Minus p power minus 1/2, minus 1/3, whatever. That case will be so if p is positive, here's the question. Can I apply that test basically? Sometimes called able test. Huh? Can I apply able test here? Can I apply that able test here? You need to keep one thing in head. Don't just blindly apply a test actually when you want to compute the series. You need to check that whether when I'm applying some theorem, some results, am I in the assumptions of that theorem actually?
A1 is bigger than A2.
Am I in the assumptions? In other words, if my given condition is satisfying the assumptions of that theorem. So do you think that if the p is bigger than 0, this sum or this series is satisfying the assumptions of the able test?
A1 is greater than
Take a n to be 1 over n to the p. Okay, and the p is a positive number. Is it satisfying that condition? Can I say that a1 is going to be bigger than or equal to a2 and a2 is going to be bigger than or equal to a3? So take n. Okay, so take for example p to be 1/2. Okay, something positive. So the first term is going to be 1 over 1 to the 1/2, and the second term is going to be 1 over 2 to the 1/2. So which one is bigger? 1 or 1 over 2 to the 1/2. So 1 is bigger, and so on and so forth. And if p is bigger than 1, then for sure this is true. That is easy to see. So if p is positive, we are in the assumptions. Satisfies the assumption. If, for in other words, for this series, I can consider basically this able series and its convergence. So consider the able series. So you have this sum that goes k from 0 to infinity and 2 to the k and a to the k. What is going to be this? This is going to be sum k equal to 0 to infinity 2 to the k times is going to be 1 over 12 power. It's like a kb. It's like a 2 to the k raised to b. And hence you're going to have what? K equal to 0 to infinity, and which is same as 2 times of 1 minus p 2 times k. Okay. Now, my claim is that now the convergence or the divergence of this series depends on p. Okay, depends on p. Now imagine you have a p bigger than 1. What's going to happen? So if the p is bigger than 1, then this will become negative. And this will become what? This will become a geometric series actually. So we proved the result about geometric series previously.
Yes.
It's like x to the n. Okay? It's like that sum actually. So it's going to converge out. So if the p is bigger than 1, for example 2, then you're going to have 2 to the minus k. Otherwise is going to become 1 over 2 to the k. And this series converges this. Because that's a geometric series. Okay. What if p is negative or p is less than 1 actually? Then this power is going to be positive. So if this power is positive, then what would be the an actually? So it's going to be 2 power some positive k actually. Okay? When you can apply the divergence test, you know that the representation of series is not going to 0, okay, and hence the series is divergent. So I'm leaving lots of things to you think for yourself. So aren't these beautiful proofs, something very simple and it's just whenever I just prove it, I just get joy. I don't know why, but I just fall in love with it. So like how something which always termed as really complex, they turn out to follow from some very simple principles. Just take something simple and okay, so now you are having kind of a big vocabulary of okay. So I'll not prove this theorem, I'll just state it, and the proof is in book, see it yourself, and it also follows from this evidence. And the proof is about this, that If P is bigger than 1, it's just a slight variant of this series. Then the sum from n equal to 2 to infinity, saying if it is from 2, not from 1 over n times log n raised to p converges. If this converges, and if p is less than or equal to 1, diverges. This close self. That's it. That's it for today. And if it's sufficient, if you can work out basically these tests and some of exercises based on that. Okay. But we will continue this discussion. This ratio test and all that. Basically, the main topic. Okay. Like we defined all this mess basically, beginning from integers and sequences and series, all that, just because we wanted to find the all. But the meaning of something will continuous. We think that the continuous means okay, left hand limit to right hand limit. More than that, we need at least 2 months to understand, to be prepared in order to see the definition of continuity. बजा कराती है। आप कब तस्वीर बुला रहे हैं?